So this video is a continuation of the chemical reaction review worksheet. The prior video I went over how to balance equations, predict the products of equations, the reaction types, and identifying if reaction is combustion or redox or not. This video deals with various example types of problems you need to be familiar with. Potassium hydroxide is reacted with iron 3 nitrate. Write a properly balanced molecular equation, the complete ionic equation, and the net ionic equation for this reaction. Be sure to show all states of matter and charges. So potassium hydroxide is KOH. You need to become familiar with the polyatomic ion chart to be successful with these. Potassium hydroxide is water soluble. AQ. You must write the AQ. It is reacting with iron 3 nitrate. The 3 means iron has a positive 3 charge. So FeNO3 parentheses 3 because nitrate is -1. Iron is +3, so we need 3 nitrates. Again, aqueous. AQ. Arrow. K is going to combine with NO3. KNO3 plus Fe with OH. Iron is still positive 3 charge. Hydroxide is always -1 charge. Therefore, FeOH parentheses 3. Okay, now we have to balance the equation. We have 3 hydroxides on the right, we have 1 hydroxide on the left. Therefore, I'm going to put a 3 in front of KOH. Now I have 3 Ks on the left, I have 1 K on the right. Therefore, I'll put a 3 in front of KNO3. I have 3 NO3s on the right, I have 3 NO3s on the left. I have 1 Fe in the left, I have 1 Fe in the right. The equation is now balanced. Now we have to figure out what the precipitate is and what's aqueous. You need to know the solubility chart. One will not be provided for you on the test. We know that all alkali metals, meaning group 1 salts, are always water soluble. Likewise, all nitrate salts are always water soluble. Therefore, KNO3 is aqueous. Hydroxide salts are usually not water soluble, unless they are with ammonium or group 1. Therefore, solid. Now we have a properly balanced molecular equation. Check. Now we have to write the complete ionic equation, sometimes known as the full ionic equation. Now in the homework for these questions, you might be asked to identify what the sum of the coefficients is. So if this happens to be a homework problem, for this step here, the sum of the coefficients would be 3 plus 1 plus 3 plus 1. So 3 plus 1 is 4, 5, 6, 7, 8. So the sum of the coefficients here would be 8. You might be asked this on the homework. Now for the full ionic equations, what we're going to do, anything which is water soluble, aqueous, we're going to split up. And we're going to include the charges. So 3 times 1K is 3K positive 1 aqueous plus 3 hydroxides, 3 OH negative 1 aqueous plus Fe plus 3 aqueous plus 3 NO3 minus 1 aqueous, arrow, 3 K plus aqueous plus 3 NO3 minus aqueous plus Fe parentheses OH close parentheses 3 solid. So whatever is water soluble, we'll split up. Whatever the solid is, we leave alone. If the question asks about the sum of the coefficients, it'd be 3 plus 3 is 6, plus 1 more makes 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Alright, so that's the full or complete ionic equation. Now the net ionic equation, we're going to eliminate any spectator ions. That's our ions which are common on both sides, and they must be AQ. So I have 3K plus, 3K plus. They're going to go away. I have 3 nitrates, 3 nitrates. So recopy what's left over. I usually write the cations first, but that's up to you. Fe positive 3 aqueous plus 3 OH minus aqueous arrow Fe parentheses OH close parentheses 3 solid. The sum of the coefficients here, 1 plus 3 is 4, plus 1 more makes 5. Notice on both sides we have 1 iron, 3 hydroxides, 3 hydroxides, positive 3, 3 times minus 1, which is minus 3, all the charges cancel. That's how we do one of those. Next question. An experiment was conducted where 50 milliliters of 0.100 molar acetic acid was mixed with a stoichiometric amount of sodium carbonate. Calculate the mass in grams of sodium carbonate required to completely react with all the acetic acid. Be sure to solve a properly balanced equation. So what we have HC2H3O2 plus Na2CO3. This will form H with CO3, H2CO3 plus H is plus 1, CO3 is minus 2, so we need 2 H's, plus NaC2H3O2. Now this reaction also involves another step. Carbonic acid will then decompose to form CO2 and water. Before I do that, let's make sure we're already balanced at this point. I have 2 sodiums on the left, I have 1 sodium on the right, so I'm going to put a 2 here. I'm going to put a 2 here. And are we balanced now? I believe so. I have 1 CO, I have 1 carbonate, that's carbonate, 2 sodiums, 2 sodiums, 2 acetates, 2 acetates, 2 H's, and we have 2 H's. That is balanced so far. This can further decompose to form CO2 and water. So let me erase this. CO2 plus H2O. You should be familiar with the decomposition of carbonates. So this is our balanced equation. We are reacting 50 milliliters of 0.1 molar acetic acid. I want to know how much sodium carbonate is needed. In order to do that, I need to multiply the volume times the molarity. 50.0 milliliters. HC2H3O2 times 0.100 moles per liter. That's what the capital M stands for. Oops, one more step. I have milliliters here, I have liters here. I have to get rid of liters. 1 liter is 1,000 milliliters. So milliliters cancel. Liters cancel. Now we have moles of acetic acid. I need to find moles of sodium carbonate. 1 mole of Na2CO3 is 2 moles of HC2H3O2. Now I need to convert moles of sodium carbonate into grams of sodium carbonate. I need to check the periodic table. Sodium is 22.99. That's sodium times 2 plus 12.01 for carbon plus 16 times 3 for oxygen. Molecular weight of 105.99. Okay, so 50 times 0.1 divided by 1,000 divided by 2 times 105.99. Check sig figs. The data's got 3 sig figs for the 50 as well as the 0.100. So my answer gets 3 sig figs. Ends up with 0.265 grams Na2CO3. So if I mix 0.265 grams of sodium carbonate into 50 milliliters of 0.1 molar acetic acid, that will use up all of the acid to make the maximum amount of CO2, water, and sodium carbonate. Calculate the concentration of KOH solution if 20 milliliters of KOH is titrated with 12.75 milliliters of 2.0 molar H2SO4. The trick with these problems here is you want to make sure you have a balanced equation first. The KOH is a base, H2SO4 is an acid. This is an acid-base neutralization reaction. H2SO4 plus KOH, acid and base mix salt and water. Salt is going to be K with SO4. Now I know K has a positive 1 charge. Sulfate's a minus 2 charge, so it's K2SO4. You need to know that. You will not be given a polyatomic ion chart in the test, so you need to know the charges of the polyatomic ions. Plus, H with OH is H2O. Now to balance that equation, 2 K's on the right means you have 2 K's on the left. Each H combines with OH, so 2 H's from the acid, 2 OH's from the base. That gives us 2 waters. Now we can solve the problem. We have 20 milliliters of base. We have 12.75 milliliters of acid and 2.0 molar acid. We don't know the molarity of the base. That's what we're trying to find. Therefore, our A is the acid and our B is the base. We always go from A to B. A gets the numbers, B's always get the question mark. I always start with the volume here. 12.75 milliliters H2SO4. 1,000 milliliters per 1 liter H2SO4. Milliliters now cancel. Volume times molarity is moles. So I'll multiply this by 2.0 moles H2SO4 per liter. That's what capital M stands for. I usually write capital M in terms of liters and moles to show how these units cancel. Now we need the mole ratio. The mole ratio is always B divided by A. 2 moles of KOH over 1 mole H2SO4. Now moles of H2SO4 cancel. I've now got moles of KOH. We now divide this by the volume. Remember, molarity is moles per liter. I need to divide this by the volume. 1 over 20. 1 over 20 milliliters. Now we have moles per milliliter. We'll get rid of milliliters. 1,000 milliliters in 1 liter. Milliliters cancel. So now we've got, check units. We have moles on top, liters on the bottom. That is molarity. Do you want me to do the math? 12.75 divided by, before I do that, notice the thousands also cancel. So 12.75 times 2 times 2 divided by 20. Check sig figs. we've got 4 sig figs in the 20.00 milliliters. I have 4 sig figs in the 12.75 milliliters and 2 sig figs in the 2.0 molar. Therefore, my answer gets 2 sig figs. Final answer of 2.6. 2.6 molar KOH. Or 2.6 moles per liter KOH. Either way is acceptable. And that's how we do these problems here.